All right, on this video, we are going to go over your second exam. So question 1, what is the balance rate? Remember, anytime we see negative, those are reactants. So if we just look for reactants of O2 and FeS, there's only one answer there. That would be D. But also remember, these numbers are your coefficients. All right, 2. Based on the rate equation in question 1, if the concentration of O2 drops from 1 to 0.85, so we're doing O2, so the numerator is 0.85 minus 1. There's a negative sign there, don't forget that. Divide by 7 times 20. So we're doing negative 0.850 minus 1 divided by 140. The answer there is D. All right, based on your answer to the rate in question 2, how much Fe2O3 would you make? So we're doing Fe2O3. So our rate was 1.07 times 10 to the minus 3. That's equal to delta Fe2O3 divided by 2 times 10. So we just multiply this number by 20, and that would be C. D, give the characteristics of a zero-order reaction with one reactant. That is A, the rate is not proportional to your reactant. 5, what data should be plotted to show the experimental concentration data fits a first-order reaction? Your y-axis should be natural log. That's C. 6. What's the overall order of this reaction? So NO has an order of 1, O3 has an order of 2. Combined, that is third. 7, which of these following statements is false? A, the average rate of reaction decreases during a reaction. That's true. B, it is not possible to determine the rate of a reaction from its balance equation. That's true. C, the rate of a zero-order reaction is not dependent on its concentration. That's false, as we just saw in the previous question. So 7 is C. 8, using the table in this graph, what is the concentration of AB at 210? All right, from this graph on the y-axis, we see it's 1 over AB. So you could go to the equation sheet, which I saw a lot of you did, and just use that equation. The graph tells you what 1 over A is, tells you what K is. However, if you thought outside the box, you would notice that I'm looking for 210, and this line is linear. So between 200 and 250, the concentration was 0.18 and 0.149. So my concentration must fit between these two. It has to. We go to the answers. There is only one concentration in your answers that are between 0.18 and 0.149. That would be 8.173. 9, the half-life for radium is 1620. What's the rate constant? All right, so 1620 equals the natural log of 2 divided by K. I can multiply each side by K and then divide each side by 1620 to get K equals the natural log of 2 divided by 1620. We do the calculation for that. The natural log of 2 divided by 1620, that is 4.28 times 10 to the minus 4. That should be A. All right, 10, for a reaction. What happens if temperature is decreasing? So as temperature goes down, you get a slower rate. So it's B or D. Now, K is our rate constant. So the lower the rate constant, the slower the rate. So that is B for 10. 11, what is the rate determining step? It is always the slowest step. So that's A. 12, the first order rearrangement of CH3NC is measured to have a rate constant of, so we have our first rate constant K1, 3.61 times 10 to the minus 15. Our temperature is 298 K. And rate constant K2, 8.66 times 10 to the minus 7, T2, 425. Now, if you weren't sure on question 10 about temperature, this actually gives you the answer for question 10, right? From 425 to 298, our K went down by a lot. But anyways, we want to go to our equation sheet for this. And we want to use our equation that has two K's in it because we want activation energy, EA. So the natural log of K2, 8.66 times 10 to the minus 7, divided by K1, 3.61 times 10 to the minus 5, is equal to EA divided by R is 8.314, times 1 over T1, 298, minus 1 over T2, 425. Right, so let me do my parentheses first. 1 divided by 298 minus 1 divided by 425 is 0.001003. Right? Now I want to take that number and divide it by 8.314. Let's do that. So taking this 0.001 and dividing it by 8.314, we get 0.000121, and that's going to be multiplied by EA. So that's my right-hand side of the equation. My left-hand side is natural log of 8.66 divided by 3.61. That's a very big number, or actually when I take the natural log, it's not. When I do the natural log of that number, that is 19.295. Then I'm going to divide it by this 0.0001 number, and you get 159,982. Now my R is in joules per mole, okay? So I'm looking for a number that is roughly 160 kilojoules per mole. The K's actually canceled out, so it's just joules per mole. Let's go back to my answer, see if I see a number that's around 160. And I do. So the answer there is A. Okay, moving right along. 13. The activation energy, so EA, is 103 kilojoules per mole. Frequency factor, so that's A, is 4.0 times 10 to the 13th. What's the rate constant? K. Temperature equals 398. So we want K equals AE minus EA divided by RT. That's our equation. A, 4.0 times 10 to the 13th. Exponent minus EA, so minus 103, divided by 8.314 times 10 to the minus 3. So I'm doing times 10 to the minus 3 because I want my units to be in kilojoules, times 398. All right, let's do this then. So we have negative 103 divided by 8.314 times 10 to the minus 3. 8.314 times 10 to the minus 3. Okay, and then we're gonna do that divided by 398. And then we're gonna take the exponent of that number. So when we do that, that's 3.03 times 10 to the minus 14th. And I'm going to multiply that by 4 times 10 to the 13th. And we get 1.2. Oops, my pen went away. So 1.2. So that is A there. All right, 14. This graph shows that as rate is increasing, or sorry, concentration's increasing, rate doesn't change. That means B, we are zero order again. 15, what is dynamic equilibrium? No reactants react? No, that's not true. No product is formed? That's not true. The rate of the forward is faster than the rate of reverse? Nope. Rate of the reverse is faster than the rate of forward? Nope. The rate of the forward equals the rate of reverse. Yeah, that's what equilibrium is. All right, which of these statements is false? When K is much greater than 1, remember, so this K, this capital K is actually KQ. So it's products over reactants. So if it's bigger than 1, the reaction is, before the reaction is favored and essentially goes to completion. That's not false, that's true. When K is less than 1, the reverse is favored and the before reaction does not proceed to a great extent. That's true. When K is 1, neither forward or reverse is stronger favorably, and about the same amount of reactants and products exist at equilibrium. That's true. When K is greater than 1 and applies the reactions very fast. That's false. KQ has nothing to do with speed. Speed is the other K. That's rate constant. So that would be D. 17, draw an energy diagram for catalyzed and uncatalyzed. All right, so, and it has to be endothermic. So endothermic means that my products are higher than my reactants. So that can be uncatalyzed. And then let's do catalyzed in the red. All that's different is that you have a lower activation barrier. So there's your catalyzed reaction. So that's what I was looking for. The difference in the humps, that's the only thing that's different, and the products are higher than your reactants in endothermic. All right, 18 is our last problem. Consider the 3-step mechanism. What's the overall reaction? Okay, so we are looking to get rid of intermediates. So I already see BR and 2Br. Let's see if we have anything else. We have CBr3, CBr3. So the overall reaction is Br2 plus CHBr3 will go to make HBr plus CBr4, our intermediates being Br and CBr3. Now, what is the rate law? So the rate law is based on the slowest step. So that's step 2. Rate equals K2, concentration of Br multiplied by the concentration CHBr3. We have a problem. We just said Br is an intermediate, so I need to get rid of that. The fast step above the slow is an equilibrium. So I can set these two rates equal to each other, as we already saw in the previous problem. So my left rate is K1 Br2. That's equal to my reverse rate, K minus 1 Br squared, because we have 2 Brs. So I need to substitute Br, not Br squared. So divide each side by K minus 1, and then I want to square root each side to get rid of that squared. So Br equals the square root of K1 Br2 divided by K minus 1. I'm going to plug that in for Br in my rate, and so my overall rate is equal to K2 square root of K1 Br2 K minus 1 multiplied by, that's supposed to be minus, CHBr3. That's the answer, the C. And that's all for exam 2. So if you have any questions about that, let me know. Otherwise, I'll see you in a different video, and hopefully I'll also see you in class. Have a good one.